All right. Good morning, everyone. My name is Michaela Pochner, and I'm the technology editor here at Strip-Till Farmer. Thank you for joining us today for Orthman Manufacturing's digital demonstration of the 1tRIPr 2 strip-till system and Tru-aPLYr dry fertilizer system. Today's presenters are Mick Goedeken, agronomist at Orthman, and Pat McNaught, regional territory manager at Orthman. Mick and Pat are going to give you a detailed front-to-back tour of the 1tRIPr 2 and Tru-aPLYr, exploring their innovative features, benefits, settings, and capabilities. Before they get started with the digital demo, I just want to let you know that we will be taking questions throughout the presentation. On your screen, you'll see the control panel with the Q&A icon. You can submit questions here at any time you think of them during the presentation, and we'll take those throughout. We're also recording today's digital demo in the event that you want to go back and watch it or share it with anyone. Thanks to Orthman, we're also able to offer a special discount on attendance at the National Strip-Tillage Conference coming up July 28th through 29th in Iowa City, Iowa. So stick around until the end of the webinar for that code. So without further ado, I'll hand it over to Mick and Pat.
Good morning. Thank you, Michaela. My name is Pat McNaught. As Michaela mentioned, I'm territory manager with Orthman Manufacturing. Joining me today is Mick Goedeken, one of our corporate agronomists. And we're here, at least to start, to talk about the 1tRIPr 2. The 1tRIPr 2, as many of you know, is our strip-till rig. Been in existence since 1998 or so. And currently we produce somewhere in the neighborhood of 2,000 to 3,000 row units a year. This is the next generation. We've had several prior to this, but this is the direction we've chosen to head going forward. I have a little bit of experience with this row unit as it relates to the 6 prototypes that I chased around for the last 3 growing seasons, and have been pretty pleased with the final design and its performance to the ground. But we'll skip all the nonsense and get right to the nuts and bolts and discuss each component and how we've changed the design and its simplicity and its ease of adjustment going forward. So like most every strip-till rig on the market, the first and most critical portion of strip tillage is being able to cut the residue. And so we use a simple depth-banded Coulter design that we've used on our 1tRIPrs and cultivators and multiple other applications for well north of 25 years. It's simple, it's proven, and it just flat out works. The Coulter cuts the residue, obviously. The depth band controls the row unit depth. As you can see, the row unit itself is mounted on parallel arms that give it a certain amount of flexibility to deal with uneven ground row by row. And the reason that's critical, and I'll let Meg touch on it after I get done, is we've learned in almost 25 years of research in strip tillage that accuracy is for fertilizer placement as far as depth is critical. And when you don't have a parallel arm assembly, it's pretty hard to guarantee that this fertilizer is going to be placed exactly where you want it. It would be no different than trying to plant without parallel arms. It would screw up seed depth to no end. But I can state, I think, with a certain amount of certainty that fertilizer accuracy is almost as important as planter depth.
I would agree, Pat. You know, over our years of research, we've figured out that depth of placement is best for the corn crop at 7 to 8 inches. And that's what we run at our research farm. That's also what we recommend to our customers. Now, how do we decide, Pat, how did we decide how deep to run this shank? Now that we're getting to that point and talking about depth of placement.
Before we get that far, I think we'll work our way front to back. My point was to point out parallel arms. And it's pretty critical. We work in a lot of rough country. I don't know how many of you are familiar with Nebraska, but we go from pool tabletop flat to canyons. And so it's pretty critical that each row maintains consistent depth in our world. You'll see that the row unit down pressure is controlled simply by 2 simple but effective springs. Again, we've used these springs for 20, 25, close to 30 years. And what you'll notice different from the old 1tRIPr behind me is we only have 2 down pressure springs on the row unit now instead of 4. Simply because we figured out we don't need that much down pressure. And we'll talk about it a little bit later, but the draft of the point and the aggressiveness of the point pulls the row unit into the ground. And I have seen 1tRIPrs running with both of these springs broke and not have any trouble keeping the row unit in the ground and maintaining depth. So simple system, easy to repair, easy to maintain, doesn't require a lot of extra cost associated with it. Overall, you'll see, it might be kind of hard for you guys to see on the video. It's hard for me to tell, but we've gone 100% cast from our front fork to our parallel arms to our row unit frame. We've gone 100% cast instead of welded steel. The reason for that is a couple things. Number one, it lowers the weight, but it maintains the strength of the welded steel that we've used for 20 years. It also makes assembly a little easier for us. Instead of welding everything together, we're simply sliding in pins and bolts and sending it out the door. But probably more critical for me in my region, because I get into a lot of narrow rows, and the current 1tRIPr, the 1tRIPr 1, if you want to call it that, will go all the way down to 20-inch rows. And I have a lot of 20-inch rows in my territory and 22-inch rows. With this row unit, which is simply not more than about 4 inches wide, 5 at the most, it's going to make it a lot easier for us to deal with those narrow rows, not in performance, but ease in setting the row unit. With our wider row units, like the one behind me, it's pretty hard. You got to be about a contortionist with 6 hands to do some of those adjustments. Tell you the truth, it's getting harder as I get older. So this will help a whole lot in narrowing up that row unit and allowing us to make easier repairs and easier adjustments as we go forward. Changing the physical weight of the row unit is also a little bit beneficial in that our toolbar and our row units are heavy. Orthman Manufacturing is not known for building things light, never has been, never will be. And so while we maintain our heavy built and heavy wall toolbars and framework, if we can cut a little weight out of the row unit and maintain the strength, it's a little easier on the tractors of today, especially for the 3-point mounted machines. We dropped about 28 pounds per row, so not a drastic amount, but still something. But going through the row unit from front to back, and you'll also notice too that we eliminated all the grease strips. So what was once 5 grease zerks per row is now 0. So we took that daily maintenance, and all of our polling of all of our customers over the years, that was something that was made very clear to us is we need to get rid of the daily maintenance and make things a little easier so we can be more productive. So I can't tell you the total number of acres on the 1tRIPr 2s that were in prototype, but once we finalized the design and the parts associated with that, we showed very little wear in 3,000, 4,000 acres. So looking forward to those machines running again this fall and evaluating them again. But I'm real comfortable in what we ended up with as far as design. Going back from the depth band and Coulter, simple row cleaner. Simple because there's not a lot to it and there's not a lot of setting to it. I've always told customers as I'm out in the field setting machines, which is something that I do pretty regularly, in heavy corn residue, and my definition of heavy corn residue is 270 to 320 bushel corn, which is areas I operate in quite consistently. We want to move 70% of the residue out of the way. I don't want to move it all because then I take a chance of moving dirt. I don't want to move soil. I want a flat field when I'm done. So the engineering group has helped us a little bit in that with this newer designed row cleaner, in that we've gone to a sharp tooth opener instead of a convex disc or concave disc, excuse me, which is a little less aggressive, but still moves the residue. And then along with that, I don't know if you can see it in the video, but you'll notice behind this disc and my hand is actually touching it, there's a spring. And so we have what I would call a semi-floating row cleaner, meaning we limit the amount of travel up and down, and we can also adjust the tension on the spring to keep it engaged. It's pretty critical that we move that residue. Otherwise, I don't care what the strip tillage tool is. If you don't get most of the residue out of the way, you've got a big expensive dump brake, and nobody likes that, right?
And Pat, you've heard me say a million times, these are row cleaners. They're not part of the tillage process. I don't want to see those engaged in the ground all the time. I want to see them floating around, and as they're getting residue, then we see them moving. I don't want to see those moving soil at all as we're going through the field.
The reason we limit the travel of the row cleaner is we don't ever want to get into a point where the row cleaner floats up over the residue and doesn't move the bulk of the residue out of the way, because this machine will plug if that environment happens. And so plugging is not something that I ever see with a 1tRIPr, very rarely. And we operate, like I said, in 20-inch rows, 22-inch rows, and 250 bushel plus corn residue. That's dry, which is extremely dry, which is infinitely harder to deal with than residue that has moisture in it because it's so fluffy. So I like this change that we've made from a fixed to a semi-floating. I like the fact that we still stay engaged and don't float up over the residue. And it's just a simple adjustment up and down. And by adding the floating component to it, our time spent adjusting is a lot less because its ability to move based on varying ground conditions. So that's been, at least for guys like me who chase these things all over the place in the spring and the fall setting them, this has been a welcome addition. Going up to this portion of the row unit. So our row unit is protected by two different options. One is a simple shear bolt. Two is what we've called for years auto reset. And that is what this linkage right here in these four springs are. So for those of you who don't know what auto reset is, if our shank hits an obstruction, this linkage will trip. It will pivot on this pin. The whole back end of the row unit will swing up. It will clear the obstruction, and it will go back down. The unique thing about our auto reset linkage is it'll do it without you raising the implement out of the ground or stopping. It will reset if you're traveling forward at 8 mile an hour, 9 mile an hour, 5 mile an hour. And if you're 12 inches in the ground, it'll reset itself, and you do not have to stop and pick the implement up or stop your forward motion. Predominantly used in rocky country, although there are quite a few places. Guys don't like to get out of the tractor cab and change shear bolts anymore, so they've opted to go with this option. It is adjustable, so we can adjust it based on the field conditions, so that it trips when it needs to and not when it doesn't. Like I said, the other option is just a similar linkage with just a simple shear bolt about in this area right here. That would be easy to change if you sheared it. And then going back to the knife. And this is probably the most critical part of the tool, to be honest with you. Mick talked about it earlier. We both spend a lot of time setting machines for customers. All Orthman field people do that spring and fall with quite a bit of regularity. And the first thing I do when I go out and I set a machine, the first tool I grab out of my pickup is a Penetrometer. And I'm looking for compaction. And I want to set this point, and I'm looking for the shallow compaction layer, the one that resides generally in from 2 inches below the soil surface down to 7, 8, 9, depending on the soil type, soil condition. I want to be underneath that layer by about a half an inch or so to an inch with this point. And then from that point, I can adjust my fertilizer placement by simple roll pins and moving these tubes up and down based on my knife depth. So if I have my, just for an example, if I'm using this liquid /anhydrous knife and I'm putting on 1034-0 through my upper tube and anhydrous through my bottom tube, I can set my point depth at say 9 inches to deal with compaction. I can bring my bottom tube up where I'm putting on my nitrogen to 7 inches. And then I can bring my 1034-0 tube up, say I want to put that on at 4 inches. And that's adjustable inch by inch whether it's the 2 liquid tubes or the other options that we offer, which are a liquid tube and a dry tube. Independently adjustable inch increments separate from the knife depth. And Mick can talk a little bit more about the compaction and why that's important.
When we think about compaction and we think about that emerging seed, when that radical emerges out of that seed, we only have a little bit of push power, 14 PSI, and that increases as we go through the season. By the time we get to tassel time, we're talking 300 PSI push power to push against that resistance of that soil for that root system. And so you'll hear me say a lot of times, let's take care of that top 12 inches, because if we can reduce that compaction in that top 12 inches to where that root can grow and proliferate and do its thing, then we're doing exactly what this machine was designed to do. And then that's going to improve our crop yields. If we don't take care of that compaction, what happens is the energy that that plant is using to grow up and down is compromised because it's using more energy growing downward than upward. And then we start to see the waves in fields where we can see the compaction. Pat and I are fortunate we live by some fields that demonstrate compaction. And he and I were talking this morning about a field that's tasseling now. And we could actually see where the tire tracks were, where that compaction was, tassels versus no tassels all the way across that field.
To add to that a little bit, so Mick and I also run the Orthman Research Farm based in East Central Nebraska. And one of the studies we did last year was a tracks versus wheel comparison. And I would invite anybody to go on the Orthman website, click on the organic or agronomy tab. Sorry, I was going to say organic. So
Yes.
Click on the agronomy tab, and you can see our 89-page yield book from last year that discusses all of our plot results. But as it relates to compaction, we farmed a portion of the farm with an 8RX tractor, or 4-track 8000 series tractor, and another portion of the farm with a 8R that was dualed all the way around. And strip-tilled both, planted both the same, everything the same, no different treatments as far as fertility, same seed, same irrigation, everything. And at the end of the day, there was a 6.6 bushel advantage to the track tractor on corn. And if you take 6.6 bushels times 2,000 acres of corn, that gets to be a pretty big number pretty quickly, especially with today's commodity prices. But the point is that even in a strip-till environment where we do a great job of eliminating the shallow compaction layer and getting that plant started off right, there is still compaction that exists. And maybe a track tractor is something to think about in your operation. Our knife depth is adjusted with a simple pin, 1-inch increments that you can see from 0 all the way down to 12 inches. The other thing that we do, and you'll notice it on all of our tooling, is that we put in jam bolts. And I know a lot of our first-time customers wonder and fuss a little bit about having to drag a wrench and tighten that thing down. But a critical point to any part of this row unit is that any of these ground engaging tools, whether it's the row cleaner, the point, the closing coulters, they need to be locked solid. Simply stated, if this knife is not locked solid, it's going to rattle around inside this cavity and wear. The smaller shank, because of the wear, is easy to fix. The bigger hole in here is not. And I've chased 1tRIPrs for the better part of 15 years now. I don't know how many hundreds of them I've set, or thousands probably. Changing knife depth and changing closing coulter depth. And I cover a 5-state area in just about every soil condition, soil type you can think of. Once we get them set, very rarely are they changed. And by keeping the design simple and locking the tooling solid, I could take you to countless machines that have 30, 40, 50, 60, 70,000 acres on them and still are running some of the original tooling from when they were new. Durability is something that Henry Orthman was known for in Nebraska, and it's not something that we're willing to give up. So we try to find the kind of the middle ground between ease of adjustment and durability. And I think we've done a pretty good job on this row unit. Obviously, we put a roll pin in here so you can't completely drop the thing out. I have done that. That hurts. And a handle to assist you with doing that. But this is probably the most critical part of the row unit. The tillage of the point and the application of fertilizer, whether it's dry, liquid, or anhydrous, or combinations of two of the three, I should say. It's pretty critical that this point specifically and these tubes can be independently adjusted to meet all the field conditions. So we'll move back and we'll go to our closing system. 18-inch wavy coulters. This is also a portion of the compaction alleviation that sometimes we don't talk about. But if you can imagine that your tractor engine is developing energy, and that energy is being transferred from that tractor to this tool, or any tool that's behind that tractor. So what we're doing with waved coulters, or wavy coulters, that are directly across from each other, is we're taking that energy and we're bouncing it back and forth between the two coulters. That does two things. It helps to fracture soil above the knife. And what's probably the most critical about that, and Mick will touch on this, is we fracture that soil and that hard pan or that compaction without tumbling or turning and upsetting the soil structure. Soil has natural pathways to allow moisture and temperature and fertility to move up and down and sideways and forward and backward. And the last thing we want to do with a tillage tool is wreck those natural pathways. If you can imagine a parabolic shank, and we used to build parabolic shank rippers years ago, long since learned that that was not such a great idea. If you have any amount of moisture in the soil, that soil travels up that shank in a curved fashion because the shank is curved, and then it tumbles. No different than a disc, no different than a field cultivator, or any tool that tumbles soil. You're destroying the soil structure in that pass. And so
that tumbling process is just like what we use to polish rocks. Those folks that have ever polished rocks, they put them in a tumbler and take the sharp edges off. We destroy soil structure when we tumble it. So that's why this is designed with this point to lift straight up and then drop down to alleviate some compaction. And then we're taking the wavies and we're actually bouncing that energy between the two and breaking up more of that excess compaction that maybe we didn't touch with that knife. And hopefully at the end of the day, we don't have a clog behind it. Now, there are certain conditions that no matter what we do, we cannot alleviate those clogs. These are designed with a 5-degree angle outward. And that's part of that is the process of breaking that, using that pressure or the energy from that tractor to break up that compaction.
So these are 18-inch coulters, same as we've used for years. The only difference being is on the previous machine, you had an independent standard for each coulter. Obviously now we went to one. Makes it a little easier to adjust. And the other thing that we've been able to create with the 1tRIPr 2 is more being able to create a narrower strip than we ever have before, and also a wider strip than we ever had before, simply by allowing these to move in. By narrowing up the row unit, we can narrow these up quite a bit more than our old row unit, which is going to assist us in the narrow row environment that I see pretty regularly. As far as depth, that's dependent on field condition. I have certain fields that I've set these where we're running just so that the hub is almost in the ground. And in lighter soils, you might only need to be 2 inches or 1 inch in the ground. Just depends on the soil condition, soil moisture, type of soil. All those factors play into how you set this machine. And that relates to the furrow opener, to the knife, and to the closing coulters. Soil conditions and soil types dictate how we set it. What I do when I set machines, because I understand a lot of farms that I travel and are around quite often go from blow sand, if you're not familiar with blow sand around here, and all the way into gumbo. And so generally what I do is I set the machine for the worst possible condition, and it'll work everywhere else. And very rarely do our customers that have been running 1tRIPrs for years and years and years and years and years change their settings. It almost never happens. Once we get past the closing coulters, simple basket assembly. This basket serves two purposes. And there's about 4 different basket designs that we offer with the 1tRIPr. This is a 14-inch standard flat basket that probably goes out on 80% of our machines. This type of basket assembly was originally designed and piloted for the Western Corn Belt, where we're dealing with areas that maybe get 5 to 7 inches of total rainfall a year and have to supplement it with irrigation, which is expensive. So we don't like to put a lot of water on if we don't have to. But what we do with this basket is number one, we don't put a whole mountain of down pressure on with it, because we just did a fantastic job with the point and the Coulter of loosening the soil. And the last thing we want to do is take the basket, pound it right back down, and install a bunch of compaction that we took out. So all we really want to do is smooth the strip, firm it up a little bit so the planter rides nice. But in arid environments and in dry environments, this is probably the most important reason why this basket was put into use. Is if this machine is running through the field at speed, and when I say speed, generally anything more than 5.5 miles an hour is where it works best. This basket will throw a rooster tail. And because of the design of the slats and the angle of the slats, what's happening is it's separating large particles of soil from small particles of soil. Obviously, as that rooster tail comes up, the heavier particles of soil are heavier and fall to the ground faster. The smaller particles reside on top. And what that does in an arid environment, which I'm really familiar with in Western Kansas, Western Nebraska, and Eastern Colorado, is it creates a seal. And it seals moisture in and allows, generally speaking, about 2 more weeks, depending on weather conditions, but about 2 more weeks of crop survivability, because we stored that moisture and we sealed it in the strip. It also doesn't affect our infiltration rates. Our infiltration rates stay the same whether we run the basket or whether we don't. And that's a product of not putting too much down pressure on with the basket. But as far as options, we have a 14-inch flat basket, which is what this is. We have a 14-inch berm promoting basket for those who like to leave a little bit of a berm in their strip. And we have an 8-inch narrow basket. It's obviously for our narrow row situations.
I know that Pat and I feel the same about this. I'm not a fan of a berm, because if I create a berm and when we run this machine, I want the soil to look just like it did ahead of it, the same height all the way across. And the reason is if I have extra height where that strip till was engaged or was processed, then I injected something there to raise that soil up. Generally, it's an air pocket. I don't want an air pocket in the strip. I want to put everything back to where it was and have a nice level playing surface. I know Pat and I hear the word berm, and I know myself, I cringe a little bit because I don't like that berm. If I have a berm, I've added air to that strip, and I don't want that air in that strip because air causes bad things to happen. We don't get infiltration correctly. Plant a seed over that air pocket, and then we don't get germination. There's several things that can happen during that with air pockets that are not good, and they're not good for us. Sometimes those trenches will collapse. You see a trench collapse, and then we've created a bad day for that corn or soybean crop that we're following this way.
One thing I will say, if this machine is set right, it leaves the field flat. Now I can set it to create a berm. If that's what you want, we can do that. But if this machine is set correctly, the field is flat, the strip will not settle because we didn't displace any soil. There's no way for the soil to settle. Even when the planter rides over it, it stays consistent. The soil, the compaction is fractured. We didn't lose our water infiltration rates or temperature infiltration rates. We simply just kept the field flat. And that's ideally what we want to do, especially in arid environments where we don't get a lot of rain and we have rolling terrain. If our strip is raised, water is going to take the path of least resistance and try to run out the field before it's going to infiltrate the strip. I want to conserve all the moisture I can get. And so I want my strip, at least, especially in an arid environment, flat so that any runoff takes the path of least resistance into the strip versus running it. I guess before we go any farther, does anybody have any questions regarding the 1-trip row unit?
If anyone wants to submit questions, you can do so using the Q&A feature. I have a question, and I think if we could have the camera pan over the row unit here while we ask so people can get a nice close-up view. You said this was the latest generation of the 1-tripper. So what farmer feedback did you get on previous generations that you incorporated into this one?
I guess I can touch on that a little bit. The two biggest things that we heard from our customers going forward were, just like I talked about, ease of maintenance, simplicity of maintenance. Not too many people like to use a grease gun. So if we could eliminate that, then that was a big positive. Ease of adjustment was another positive that most of the farmers that we deal with requested. Most 1-tripper owners are generally 1-tripper owners for life, and there are very few, at least in my travels, that trade their machines for something else. And I can take you to several who have done that and then gone back. But narrowing up the row unit was probably for at least my territory, one of the biggest things is to help our growers with narrow rows. There are a lot of sugar beets grown on 20 and 22 inch rows. There's a lot of corn grown on 20 and 22 inch rows. And so the advantages of strip till apply to those guys just as much as they do to somebody in a 30 inch row system or a 36 or a 40 or a 38. So it was critical that we keep innovating to move that process forward. And then also come up with designs that hold true to our values of being tough and strong and durable and long lasting and keeping the costs down. It's a crazy world we live in now with supply chain management issues and COVID issues. So solidifying the supply chain and making assembly easier allows us to help keep costs down. And simply, the bulk of our growers tell us improve the simple things because we love the performance. Leave the performance alone. Don't screw that up. It's not broken. Let's not fix it. But simplify the row unit, make it easier for us to maintain, make it easier for us to walk around it and work on it if we have to, or if we have to service it or change a setting. So all of this design is pretty much driven by that and not degrading our performance. In fact, I would actually say that we've improved our performance simply because we changed the knife point from an old design to this new design. For those of you who are familiar with the 1-tripper, the old design, we simply added this second wave into the point right here. And I have a 4-row plot machine that I've used for 4 or 5 years that has the 2 old style points and the 2 new style points. And I can tell you with absolute certainty that this new style point will fracture about 20% more of the root zone than the old one. And then also it's proven because we changed the metallurgy to have a longer wear characteristic. And the good news for our existing customers is it's the same mounting point as our old point. So once we turn these out into the marketplace, you'll be able to get those advantages on your old 1-tripper without having to trade for a new one. Simply replace the point. But those are kind of the drivers from our customers that steered us toward this design.
The number one thing, we didn't want to change what this thing did below the ground. And that was number one. We wanted to continue to have good strip till making abilities, but we didn't want to so we didn't want to compromise that. We wanted to continue to be able to do that or improve it. And like Pat says, the point itself did some improvements there. When we dig behind the 2 different points, we can definitely see the differences.
Talking about the points, one of our viewers asked, is there a wear life difference between the new 1-tripper point versus the old one?
A lot of that's going to be predicated on the compaction in the soil and the soil type. Obviously, sandier soils wear more than heavier soils. But if you look at my 4-row demo that I've had for quite some time now, 4 to 5 years. This is just what I'm seeing in the fields that I pull it in. I'm seeing almost a double life expectancy of the new point versus the old point. And that's simply because we changed the metallurgy, the ingredients, so to speak, of the metal. But if I had those 2 points with me today, I would lay them down side by side and you'd see a very drastic difference in the exact same amount of acres. But I'm fairly comfortable at least talking about that machine, that it's looking to be about double. So I think you could easily say, at least increasing the wear length by another 50% or better is pretty safe assumption on my part.
Okay, thank you. Those are all the questions for now. So
I guess we'll move over to the tool-bar.
Yeah, that sounds great.
Okay.
It's 10:37.
Okay, so we spent a little too much time on that, but that's okay. We'll crash a lot through here. So it became very apparent to us several years ago that more and more dry fertilizer was going on in a lot of our areas, and it came down to the time that we needed to enter into the dry market. So the Tru-aPLYr system that you see in front of you is something that we've been working on for quite some time. Ran 3 prototype machines, this being one of them, over the last 3 seasons, and tried concepts, changed things, the whole prototype process, and ended up with the final design, which is what this machine shows today. A lot of people ask me, what can you do on dry fertilizer to make the situation better or simpler, or what's the improvement over what's on the market today? And I think, in all honesty, we've come at this in a pretty revolutionary way, and I'll go over some of those points here shortly. But this system right here is a 12-ton twin bin system, 2 6-ton boxes, with 4 separate sections on each box. So this system allows you to do section control, whether it's a 12-row, 16-row, 18-row, or 12-row, 16-row, 18-row, 8-row. We can do section control based on the number of rows. So on a 12-row, you would have 3 sections of 4. On a 16-row, you'd have 4 sections of 4. On an 8-row, 2 sections of 4. But that's pretty common across the industry. Where we start to kind of steer off the rails a little bit and go our own direction is we use, for our meter boxes, electric motors instead of hydraulics. So I don't know if Krista can get in here and see very well, but this is a 12-volt DC electric motor. There's one on each meter box. And what electricity has allowed us to do, several things. Number one, it's simpler. It cleans up the design. We don't have a whole bunch of hydraulic hoses running all over God's green earth and cluttering up everything. It takes that hydraulic load away from the tractor. We know, because of our experiences with dry carts in the past, that hydraulics start to heat up the oil, especially if you're running lots of hydraulics, and that takes away from the performance of the tractor. It also robs horsepower that I can use with the 1tRIPr to do things inside the soil. So the number one reason to go to electric motor was drop that hydraulic horsepower. Number 2, simple. I just have a simple battery connection to the tractor with a plug at the back of the tractor, plug it in, my meters are powered, no separate alternator, no batteries on the cart, nothing, just plug it into the tractor and go. Accuracy. Electric motors are far more accurate than hydraulic motors. Now, once an electric motor or a hydraulic motor reaches rate, the accuracy is very consistent. Where an electric motor gives you an advantage is a quicker reaction to rate and a quicker smoothing to rate. So as you can imagine, when we set the implement down at the end of the field, and we start to go through the field and we immediately speed the tractor up. If you look at that as a curve, an electric motor shoots up faster and comes down faster and lands on rate and stays there, as opposed to a hydraulic motor, which may do this for a certain period of time before it lands on that rate and stays on that rate. And that's exacerbated by using a map-based prescription because you're changing rates going through the field. This system will do a map-based prescription very easily. With our standard rollers, we can apply basically anywhere from, depending on the product and the product density, anywhere from 50 pounds an acre all the way up to 750 pounds per acre at any given speed. For the lower rates, like micronutrients, we offer a smaller peg roller that can go anywhere from about 10 pounds per acre to 150 pounds per acre. But back to the electric motors, it's super simple. It's a simple gear drive from 2 gears, one on the motor and one on the roller. No chains, no maintenance, no wear points, or there are wear points, excuse me, but no wear points that are unnecessary. The other thing that electric motors allow us to do is turn compensation. So if we go around a curve, which especially if you get out into the western parts of my territory where we farm in circles, your outside is always applying more than your inside. We can do that with electric motors. We can, if we're going around a curve to the left, this motor will put on less product than the far motor out on the right. So with the quicker to rate feature and turn compensation, and a lot of these other things, we increase our accuracy. The best example I can give you is one of our customers that ran one of the prototypes, did 3,300 acres in one season, and added up his scale tickets at the end of the season, was 2.5% off on his as-applied rate in 3,300
prescription based.
That's a pretty astronomical number in my world. The other nice thing about electric motors, other than the simplicity of it, there's a couple other things. Number one, if we get a rock or some sort of an obstruction, the electric motor has kind of an internal, I call it an internal shear bolt. If it senses a certain amount of torque, it will stop and it will warn you on the display and tell you that there's an obstruction in that motor. It will stop the motor to prevent damage. You simply get out, clear the obstruction, and away you go. Nothing broke. That's simply achieved by sensing the voltage or the resistance, I should say, in the motor itself. The other nice thing about it is if I want to do a calibration, this is going to be really hard for Krista to get the camera on because it's stuck underneath. But there's a button right here. I can turn these motors manually simply by pushing this button and do my catch test without running back and forth between here and the tractor cab. Real simple, real easy. And I can do independent calibrations for all 8 motors in this situation or however many, or I can do a full machine calibration, however I want to do it. It also offers auto cal. So this machine can auto cal as it goes through the field. So that customer example that I gave you that was 2.5% off did 1 calibration prior to starting and achieved that level of accuracy. Now he had very consistent product and he used the same product from the same supplier across every acre, and that helps. You start using different products or the same product from different suppliers, you end up with some consistency issues. You'll probably lose some of that efficiency, but if you've got good product and it's consistent, you can be wicked accurate. The electronics of this system are provided by, many of you are familiar with SurePoint Ag, formerly Surefire Ag. So if you're familiar with SurePoint's, I'm going to screw that up for you. SurePoint's Sentinel system on their liquid, this dry system is very similar to that. And unfortunately, the card isn't hooked up to the tractor right now. Otherwise, we jump up in the cab and look at the display. But it's an ISOBUS compatible system, plug and play with the John Deere 2630, 4640, AFS. Anybody who's ISOBUS capable, plug into the back of the tractor and go. On to a few more efficiencies. Again, something I can't show you, but something that's into the design is the Venturi system where we deliver the air is fairly quite a bit different than what's on the market today, which creates a much more efficient delivery system. So even if we go up to a 16-row machine and we're delivering some of these higher rates, like this system right here, this particular customer was going anywhere from 120 to 450 pounds per acre. We only need 1 fan. And that fan is efficient because of its design. The Venturi is efficient because of its design. We can run that fan slower, and we can lose some more of that hydraulic horsepower that we're robbing to keep everything moving in the right direction. So the delivery system of air is very efficient. So the fertilizer delivery is very efficient and consistent. All of which, if you add to the electric motors versus the hydraulic, translates to less horsepower coming from the tractor just to deliver the fertilizer. That's more horsepower I can use to put the tool in the ground where I need to do good things. Simplicity of the design, you'll see here, multiple access points. I don't know if you can come in here, Krista. I'm going to squeeze in behind this tire. Our simple trap door here that allows product from the bin to come down to the meter, which is on this shaft right here. And I don't know if you can see it, but it's just a simple pillow block bearing. You simply remove this pin, pull it out, pull this cover off, and you pop the meter out. It's pin on either side, a couple of minutes. Obviously, you can see from the pictures that everything is stainless steel. Then we have an access cover here to assist in clean out at the end of the season or when the bin's empty. If we have an obstruction, we have 3 separate panels here that are simply removed if you need to service anything. And then obviously we have a simple lever here for a drop door to do a catch test or also to assist in clean out. And it's also going to be real difficult for Krista to see, but going through the meter box assembly here, it's very open. We don't get a lot of fertilizer building up in here because everything is sloped. And if there's spillage when you're filling or anything like that, it tends to run off the machine, which assists us in longevity and durability. Each motor is fused here. So if there is a problem with the motor or something that an electrical load, it'll pop the fuse and will protect the motor so that we don't have to replace the motor in the event of an electrical issue down the line. This particular system is on what we call our XG chassis, which is a pull type 1-tripper. It's probably a little hard to see. 480 80R 50-inch tires. Obviously, we have we will have, shortly, tune in a steerable cart of our own, so we can put this same system behind a mounted 1-tripper, or air boom, or a cultivator, or any other system that you would like to use to deliver dry fertilizer. Very simple. It's 3 hydraulic hoses, an isobus connector, and a constant power harness, and that's it. Plug it in, go. And like I said, it's been wickedly accurate, at least the ones that I've chased around. Scales on both bins, obviously. Isobus scales, so they show up on the display. Simple to change rates, simple to bring in prescriptions. Like I said, if you're familiar with any of SurePoint's liquid applications or anhydrous applications systems, the screen in the cab is going to look very similar to that, real similar to that. So, Mick, I'll let you step in.
The cart itself will come with 3 lights, one between the bins, one in the back, and one in the front. And the way I understand it, those are going to be able to run independently. A lot of guys like to have the light on behind and when they're running at night so they can see their bin levels. And so that's one of the things that we've added to that system just to make it a little bit easier. You know, being accurate on map-based prescriptions gets us more improvement on our precision placement of nutrients. And when you think about that, we want to get to where we're getting our most efficiency out of our nutrients, and something like this in a dry cart gives us that capability to do that. Unfortunately, we're never going to be row by row with this machine, but if we can do it in sections, we're doing a lot better job than we were 20 years ago when we were treating whole fields with the same amount of fertility.
The configurations, as of right now, this is the only offering, a 12-ton twin bin system. Obviously, with twin bins, you can run 2 different products, or you can run the same blended product, or however you want to do it. This particular chassis is on 480 or 50-inch tractor tires, which we also offer in duals if we get into compacting soils issues, and we also offer it in tracks. So tracks are something that you like. We can offer this system with tracks. 12-foot loading height, big openings, great big openings, with a screen obviously to facilitate catching any big chunks, so we don't create problems down the line. Because of the bin design, the plastic bin itself, it cleans out almost perfectly. We have good flow down to the meters, so there's very little leftover product in the bin once you run out. Does anybody have any questions?
Yes, we did get some questions in. I'll start with the ones about the Tru-aPLYr. So we have someone asking, how much power does it take to run an 8-row with the fertilizer cart?
If it's an 8-row 1tRIPr, depending on soil condition, a good rule of thumb is 25 to 35 horsepower per row. And that's predicated on a lot of different factors: soil type, density of the soil, moisture level, depth of compaction. But 25 to 35 horsepower per row is pretty consistent. We'll hit just about every field condition that you can come across. When you add the Tru-aPLYr to the system, I don't know if we've run those numbers yet to see how much of an extra load that creates. I know this particular customer, I'll have to look here, has a 16-row 1tRIPr that was running 7 inches in the ground, pulling this Tru-aPLYr, and he has a 9520RX John Deere tractor. So he told us he was able to run a 9 mile an hour with no problem. I have seen a 12-row. One of the prototypes was a 12-row with a Tru-aPLYr and also pulling a 1,500-gallon anhydrous tank behind it. That 12-row was run behind an 8360 RT tractor, and Jeremy had very little trouble with that. So that's kind of a difficult question to answer, just because it depends so much on soil conditions and soil type.
Sure. And then we also had someone ask, does the system come standard with separate scales and bin level low sensors? Yes.
Yep. The system comes standard with separate scales and bin level sensors. That is correct.
Okay. And then we did get another question about the 1tRIPr 2. Jacob asked, what are the diameters and thicknesses of the lead Coulter and closing Coulters?
So the closing Coulter is an 18-inch Coulter. And honestly, it's an 18-inch Coulter, and the cutting Coulter is a 22-inch Coulter. That's what we've run probably for the last 20 to 25 years. And I have yet to find a situation, generally in my world, because I'm not always out just setting new machines. We have new customers that buy used machines and often ask us to come out and help them. And on the depth banded Coulter, what I like to tell people is a good rule of thumb is I've seen these worn down to where the Coulter is only an inch above the depth band and still works. It just depends on your residue. It has to be good enough to cut the residue. That's all that matters. But in certain environments, even down to an inch off of the depth band, it will still work. The other thing I should point out is the Coulter is independent of the depth bands. So again, it's a 22-inch Coulter, and if it does need to be replaced, you don't have to replace the depth bands with it. It's a separate part than the depth bands. The closing Coulters, this will just give you an example. They're 18-inch Coulters. I can take you to a lot of machines after 10,000 acres. They haven't changed them, but I did look at this machine this spring, or just before we started. So these Coulters here have been over 3,300 acres, and they're down to 17 and a half. So they were half an inch at 3,300 acres in a very heavy sandy soil. Probably one of the worst environments that we can operate in other than blow sand as far as wear. But 18-inch for us gets us to the depth that we need to get to deal with the compaction that the knife can't take care of because it's deeper than that. So that's why we choose to go with those diameters.
Okay. And I know earlier you mentioned that for the 1tRIPr 2 and previous 1tRIPrs, you've set the machine when the customer first gets it, and then they never change it again because it's doing the right things that it needs to be doing. Is setting up the machine something that you guys always do for customers, and what does that process look like?
Every time we get an opportunity, I'll put it that way.
If we know there's one that's been used and sold on the used market, and we get a call from the person that bought that, we will do our darndest to get there. We just ask for a couple days notice. Don't call us in the morning, tomorrow morning, and say, hey, can you come set this 1tRIPr, because we already got plans, or we might be somewhere else clear across the country.
But as far as contacting us, it's usually two ways. Mick and I and all of our other TMs, our phone numbers and email addresses are on our website, and you can contact us directly. A lot of times the contact to set a machine comes through the dealer that sells it. So we have a salesman at one of our dealers that sells a machine to a customer, and they call and ask, can you come out and help us get it going? And we do that a lot. The bulk of my spring and fall is spent setting 1tRIPrs. But just as an example, I generally keep a pickup for about 2.5 years and put 250,000 miles on it. And a lot of that is chasing 1tRIPrs. And it's something that we truly love to do. I'm not going to sit here and tell you we know it all, because we learn something every time we set one. But we do have a lot of experience, and we've seen a lot of things. And I encourage customers to take advantage of that service, number one, because it doesn't cost anything. And we can speed up the process. A lot of times I can go out, kind of look at the field, and I can come into the shop and I can preset this machine, and we'll spend very little time out in the field changing anything before we get it to go. The other thing, as far as settings, we know this from a lot of research. We do a ton of agronomy research, publish a lot of agronomy research every year. And we've been doing it for 25 years. About year 3 of strip tillage with this row unit, you start to change 3 to 5, depending on the soil conditions, soil type, climate, a few other things. You really start to change the dynamics of the soil, and you start to improve that structure, and you start to improve the water infiltration rates. And once you get to that point,
don't forget the microbial population, Pat.
I'll let you talk about that. But once you get to that point, there's absolutely no reason to change the machine. And I have a good friend that I help at home when I have time, which isn't very often. Neighbor, we grew up together, and when I have time, I come out and run his machine for him. I set that machine when it was new 13 years ago, and we haven't touched it. It is still, it's a testament to Orthman reliability, because it's still running some of its original components and covers about 1,400 acres a year. So 1,400 times 13. It still has some of its original bearings in it. Obviously, a lot of the wear parts have been replaced, but toolbar's never been touched. Parallel arm bushings have never been touched. We're known for our durability, and we're not going to sacrifice that with this design. You can talk about the microbial.
Yeah, like I reminded Pat, year 3 to 5, we start seeing that soil health coming around, the microbial populations coming back to life because of things that we did in the past that hurt those, and we start using strip till to farm the microbial population. And the way that we're moving the residue to the center, they're still able to feed off of that. So we have our, in one of the terms that my predecessor used, and I've heard Pat use, we have the hay for our microbes. That's a way for some of those livestock guys to understand it. Our residue, we got to think of that not as waste product or anything like that. It's hay for our microbial population, so it's their feed. And by year 3 to 5, we start really seeing that pop out of that microbial population. The soil has the smell of healthiness to it, and we noticed that at the research farm this year as compared to last year. It's showing up a lot healthier looking soil. Our soil structure is coming back because that farm was dished to death prior to us taking it over. And so now we're starting to build our soil structure. Here I am a few weeks ago laying in in the corn rows, taking pictures of the soil structure that's coming back. It's really an exciting time for us.
One thing I want to point out that's kind of independent of the tooling, and I would encourage anybody to look at it if you get a chance. We do a lot of research. Our published book from last year, which is an online flipping book, is 89 pages long. And a lot of our research is independent or separate from research on strip tillage. We've been studying strip tillage for over 25 years. We know it works. We don't need to prove that over and over and over again. We know this works. We're real comfortable in saying that. So why do we continue to do research? Well, as a manufacturer of strip till tool, and our 1tRIPr is our #1 product. We sell more of it than anything else. We need to understand the whole system. And so we need to understand what fertility products are we using? What rates are we using? Are we using foliars? Are we planting different populations? All of these factors play a role in.
Oh, it looks like we may have lost you there. The screen is frozen.
Tried side dress trials, which are unrelated to strip till. But if they can benefit the system, the strip till system, it behooves us to understand them and be able to educate our customers on how they work.
We looked at dry versus liquid fertilizer, and we have an in-depth discussion in that book of the differences between dry and liquid, and the pros and cons of both of them.
The compaction trial that I already mentioned. This year, some things that are going on at the research farm, just to give you some examples. We're doing a starter study with 5 or 6, 7 different starter products on corn. We're doing foliars, different foliar products on corn. We're doing different loading rates, meaning we're front loading more fertilizer on some plots and rear loading more fertilizer at side dress on some plots, trying to find that unique and adequate balance. So there's a lot of information that we publish out there that anybody is welcome to. Please get on our website, click on the agronomy tab, and pull up the book and read it. We're always looking for ideas. If anybody has anything that they would like us to take a look at, I'd hate to guess how many research sites we have across the United States, or literally all over the world, but it's a bunch. And we publish the ones that we can get our hands on, even the ones that are independent from us. So there's a lot of data there, and it looks at the strip till system as a whole and not just the tool. And it's really cool, some of the stuff we've seen. And the other thing we're not afraid to do, so on that compaction trial that we discussed earlier, we break down each trial into dollars and cents. So it gained us X amount of bushels, or it lost us X amount of bushels. And we translate that directly to what we sold the commodity for on the farm last year. And we tell you whether it was a loss per acre or a gain per acre and the exact number. We're not afraid to share that information.
Is there an ROI for the grower? That's the important thing. If we're going to do a product or a practice, is there an ROI? And one thing you didn't talk about is our no-till versus strip-till trials that we have at the research farm. Are we 100% no-till on those no-till trials? Technically, when we pulled the stumps on those, so was there some tillage to add? It's all we did is we did surface applied and pulled stumps versus the strip-till environment. I still say that's a good comparison of looking at 2 different environments. Because we're ridge till, that's the reason we pulled the stumps.
That now we're starting to rocket into cover crops. About 2 weeks ago, we applied an interseeded cover crop to our corn crop that was about ready to tassel with a drum, and that was pretty cool. And that crop is about that tall right now and starting to grow. So we're excited about that. We're excited that we're going to plant some more cover crops this fall and continue to understand that environment and how it can help and benefit the strip till system. All this stuff relates to the strip till system, but it's independent of it. And it's critical. It's absolutely critical to us that we understand everything from start to finish on how we make the whole system work.
That's great. And encourage everyone to check out that research. I know we're a little past 11 here, but if you guys have a couple more minutes, we can kind of power through some of these questions that came in the last couple of minutes.
Perfect. We have all the time in the world.
Okay. So let's start with, what is the max rate at 8 miles per hour with 62-pound material?
Well, oh man, now you're asking me to do math. How many rows? Number one, that would be a critical question. Is it an 8-row machine, 12-row machine, 16-row machine? I can tell you, this machine right behind me is a 16-row machine. They were going 9 miles an hour and applying 450 pounds per acre in certain environments with no trouble. So hopefully that maybe gives you an indication.
That would have been a product close to that 62-pound.
It was either
density.
MES or 1152O or something similar to that.
Okay. And then we have, what is the minimum row spacing you can get with the new 1tRIPr?
20-inch rows.
Okay.
We're working 15s.
We're Pat and I are praying for 15s. So
20 rows as of today in the catalog.
Excellent. And then someone asked, you mentioned the row unit is able to travel 8 inches, I believe. Do your toolbars also have wing flex?
Yes, they do. And that is on our on our tillage row crop toolbars. If I remember correctly, I want to say that's 8 degrees up and down from the wing point to the end of the toolbar, which gives us quite a bit of flex. We have some really rough, some people find it hard to believe, but we have some really rough country in Nebraska. I mean, really rough. And if we can play in that market, I'm pretty confident that there isn't any place we can't play. But 8 degrees up and 8 degrees down, so a total of 16 degrees on the wings, plus 8 inches on the parallel arm itself. Deal with a lot of terraces in Kansas, especially, and there are fields north of where we're at today, and east of here where a lot of times you're not going to see the pivot or the tractor or anything because it's hidden by the hills. There's some pretty rough country here, and we generally don't have any trouble with dealing with that.
Okay. And then we have, is there an old style shank on the 1tRIPr as there are no side covers for the tubes? Does it come standard?
So the only side covers we have today are on our dry shank to protect the dry tube because it's so much wider. On our liquid shank, what we do is we rely on, I don't know if Krista can see it real well, but we rely on beads of hard surfacing. And understanding that Nebraska has a lot of very heavy sandy soils, blow sand, sugar sand, just about any kind of sand you can think of. And we've used this design for years. A lot of our customers, I've done it myself more than once, find it not too hard a process just to go ahead and add on to the bead with more hard surfacing and increase the life of the shank versus a side plate that you actually have to replace. The challenge with the side plate is you're in the dirt and you're in fertilizer, and those side plates are bolted on, and rusty bolts create headaches. We all know that. But this is a pretty simple system. The machine I mentioned earlier that's 13 years old, I personally rebuilt those shanks once. Now that was a heavier clay soil, not as abrasive as sand, but we've been pretty happy with just using simple hard surfacing beads to protect the shank. And as long as you keep up on it, that shank, as long as you don't bend it, which it doesn't happen very often, will last forever.
Okay. And then I think you may have touched on this earlier, but how much lighter is the new row unit in comparison to the old one?
28 pounds per row.
Excellent. And then Bob wants to note that you guys are awesome, and that wraps up our questions for today. All right. So I want to thank Mick and Pat for joining us today, and everyone in the audience who submitted their questions. If you'd enjoyed this presentation and you're interested in learning more about Orthman's innovative strip till and dry fertilizer systems, You can visit them at the 9th Annual National Strip Tillage Conference being held July 28th and 29th in Iowa City. And as a title sponsor of the conference, Orthman is giving you $50 off your conference registration when you enter code Orthman at strip-tillconference.com. And then as a reminder, today's presentation and audio will be made available on the Strip Till Farmer website if you'd like to go back and watch again or take a closer look or show it to anybody in your farm crew. You'll receive an email within 48 hours with the recorded presentation, and it's also available on strip-tillfarmer.com. So on behalf of Mick, Pat, Orthman Manufacturing, and Strip Till Farmer, thanks to everyone for joining us today for this digital demo. You can reach out to me to let me know what you thought about the live event and if there's any topics you'd like to see us cover in the future. With that, thanks again, Mick and Pat, and hope everyone has a great day.